What's that? Oh, look at that. Thank you, Jess, because that would have drained the battery with that little screen on. Perfect. And now it's charging, it looks like. Ish. I think so, yeah. Kind of. There we go. Okay. That's not good anymore. Now you can do this. Because we're not using the screen, we can just do the floor. Yay, for high technology. All right. So last time, we were bridging a gap. We had discussed for a couple days things called measures of center. And we had bridged from that into, and I'm going to put measures as plural, even though we only really focused on one of them. Measures of variation. Grab either one of those topics and tell me what you remember about either one of them. So either center or variation, and grab me any piece of those two topics that you remember. Anything at all, whether it was one of those measures, whether it was the big idea of one of those measures, why we care about measuring this kind of stuff, anything at all in there. What do you remember? Corey, go ahead.
Average, median, mode.
Love that, my friend, love that. So we've got an average or a mean, good. I'm going to put that mean in parentheses just because your book, and I think most journals will interchange average and mean, love it. Median and mode. And I want to actually go off on that as well. Great question, a great statement when you say average. A student in my last 243 asked me, so when somebody says average, do they mean that one? And the answer is not always. Not always. It depends on what's being measured. So if you're talking about, say, for example, the average weight of something, then yeah, chances are they're talking about either this or this. They're probably not talking about this. But if they're talking about qualitative data, the average of qualitative data, they're most definitely talking about this. So when we say average in here, we're going to be talking about add them up and divide them. But realize that word is not universally described as such. Thank you, Corey. Add to those friends. Why do we have 3 of them? Why don't we just have 1? Just to make life harder?
One doesn't cut.
Why? Why doesn't one cut it, Lucas? Go.
We can't get the right information that we're looking for.
How come? I love this. I love this.
There's so many different things that we want to calculate that there's no way that one method would be able to figure it out.
So what does this one talk about, for example? Mode.
The most.
The most, that's right, the mostest.
Yeah.
The mostest.
We're all going to remember that.
The mostest, the most frequently occurring. Why do we care about that? Why don't we just add up and divide by how many we've got? Why would the most frequently occurring something be important to us?
Well, in some situations we want to know, like, well, how many of these things should we stock? You know, like,
good.
Let's say that. And then
good.
Most of the time we sell 10 of these, so let's stock 10.
Love
instead of like
Lucas, you have just tied all these plus this together beautifully. You didn't realize you did it yet.
Thanks.
No. What he just did was, you just tied the entire point of today together into one big. This is great. It's the kind of thing engineers have to do all the time. How strong should we build that bridge? And strong enough. Well, strong enough. Okay, but strong enough for what? For most cars? For the car weight that shows up the most? Well, I wouldn't do that. I would want to make that bridge strong enough for the maximum car or maximum vehicle that might go across that. Yeah. Well, how do you determine that? Again, that's where all this comes together. So thank you. We're going to come back and revisit that all day. Thank you, sir. So yeah, the mode's great. I love the idea of restocking something in a store. It's qualitative data. Cheerios, Crispix, Kix, whatever else. You know, you've got qualitative data. What's moving the most? You're counting up these qualitative things and you're looking at the modes. Good, very good. So why do we care about these then? What does this one do? For example, the average. What does that one do? What are you actually calculating when you calculate an average?
Equal shares. Very center of.
Going like this, yeah. Right? You're putting stuff on a balance scale and figuring out where it balances. You're throwing keys into a spittoon and then give everybody the equal number of keys. Yeah, so the words we were using were balance, equal shares, love that, equal shares. So basically, yeah. Equal shares, data socialism. That's exactly what it is. Socialistic data. You're taking all the individual values, putting them into a pot, spreading them out equitably. Yep, that's exactly what it is. So why do we need this at all? I mean, it seems like we've got really good ideas. We've got this idea of an equal share and then an idea of a greatest amount. I mean, what's the point? Well, first of all, what is this?
Absolute center.
That's absolute center. Go ahead, Sarah.
The geographical center.
Good, absolute geographical center. Good, I like that. Absolute geographic center. What were you going to say, Athena? I cut you off.
No, that's what I was going to say.
So, there's an L in there somewhere. There we go. Absolute geographical center. So, why do we like to have all of them? For example, what does this do that this doesn't, or what does this do that this doesn't?
It's easier to find the median if you want a quick reference. For an average, you're going to have to do some work to get there.
Believe it or not, with technology, it all becomes just about, believe it or not, with the handheld technology we have, that's the hardest one to find now. Because these two will be given to you automatically by the built-ins. This is the one that actually requires some scouring to look for. Believe it or not. So I do agree with that. In general, manual calculations, we're kind of done with manual calculations, honestly. Because, I mean, once you understand this, and clearly you guys are understanding this, there's no need to constantly harp on adding and dividing. So we can not worry about like the ease or the difficulty of getting the data. More big picture. Let me ask it a different way. Is there any data set you shouldn't, or maybe you should be concerned about using an average on?
Well, you were talking earlier about the grades when we had, if you have, what is that graph called where they're two?
Bimodal?
Bimodal.
Yes, but two mostists?
Two mostists.
Dual mostists? These are the jokes, kids. So yeah, because then the average is going to be somewhere between the modes most likely.
Nobody has that average.
And nobody actually has that average. And when we say nobody, we don't mean nobody, we mean a very small percentage has that. So when you have bimodal data, you might not want to use averages, or medians for that matter. What other kind of data might you want to reconsider using an average on?
The snow days in Oregon.
Snow days in Oregon? How come, Tabitha? What kind of shape did that graph have? Have a hard time conjugating verbs. Remember, we actually looked at the average amount of snow in town per winter. Was it a bell curve?
No, it was
No, it was brrr, and then it had a long tail. What do we call that? Skewed data.
Right.
Skewed data. And it happens. It happens quite a bit. Skewed data. When you have skewed data, what does the average chase in skewed data? Does it chase the tails or does it chase the humps? It chases the tail. It goes towards the extreme values. So you gotta watch this guy when you have highly skewed data. And part of defining highly skewed is what this class is all about. Like, how do you define skew? We're gonna get to that as we go through. I wanna focus mostly on uniformly symmetric data today, like bell-shaped data, what we call it. I wanna focus mostly on that today. Because with that, these three are all basically the same exact thing. Skewed data is interesting. How to deal with skewed data is even more interesting. And we'll deal with that as we go through the class. Lucas, go.
Well, with the average, another reason why some situations you don't want to use it because you lose the actual data.
You do, don't you?
Yes.
You do. You do. Now, sometimes you can synopsize a data set using an average, and if you have the raw data itself, you have a comparison. And that actually ties us right into this. But that's a very good point. Any of these are a generality. What you're trying to do is take an entire set of data and break it down to one number, where that one number essentially is giving you what is a typical member of that data set. So as soon as you do that, you lose something because you're going from very specific to very general. One way to overcome that, as we saw with Bert and Ernie, what was the problem with Bert and Ernie?
They weren't the same.
They weren't the same, but they were the same.
No.
But they were.
Same amount of numbers.
Same.
But they didn't perform in equal.
Consistency was a difference. So we can make up for some of that loss, that generality that we get, and we kind of filter it down to such a singleton value. We can talk about variation, which measures either inconsistency or consistency. There we go. Thank you at home, spelling. So, inconsistency or consistency. What other words come to mind when you hear variation? Or do we just like that word? Or those words?
It gives you the plus and minus of the center
Like that.
of the average.
Plus and minus. I like that very much. We're getting into that a lot today. That's kind of like the whole point of today is getting into that idea of plus or minus, yeah. We're going to play with two data sets. That's all today. And we're going to just drill into them until there's nothing left of them, because I want to drive that plus or minus idea home, because it ties right into what Lucas was talking about the idea of knowing how to do something. What should you build or plan or purchase or sock away for the future based on? And it really has everything to do with that plus or minus. It really, really does. Cool. Any other ideas? We did talk about a measure. What was the one measure I want to focus on? That's why I put this S in parentheses. It really isn't even there. I mean, really, there's one.
Sample standard?
Yep, the sample standard deviation. Yeah. Call it just S. Your TI calls it S. We'll come into him today. Again, we'll use him a couple times today. Sample standard deviation. What is he? I don't need a formula. I don't want a formula. Formula was terrifying enough. I heard some dry heaves last class when we put that on the board.
Keep over it.
Tabitha, nice and loud, my friend.
On average, how far each data point is away from X bar?
Yes, that's perfect. That's perfect. On average, if you take each data point, and you figure out how far away it is from the average of the data set, it's the average of those distances. So when you say it, did you hear her say the word average twice? You have to. It's the average distance from average of the data points. And it gives you an idea. The bigger S is, the more... Terrible question. Terribly phrased question. Two data sets. One has a very large S, one has a very small S. Forget their averages for a second, because I don't really care. I don't really care about the S's. The data set that has a very large S value is what? Inconsistent. Good. Other words?
More errors.
Wider range, more error, statistical error, more error, wider range, inconsistent. The one that has a smaller S by comparison is awesome. Is awesome. New definition of small S value is awesome. more consistent, more
Predictable.
Say that again.
Predictable.
Good. Less uncertainty. That's a good point, actually, Lucas. Going back to your idea of purchasing for a. Suppose you're going to buy. I used this example last class. I think it worked. You're going to buy tires for your car, and there's like two brands that have essentially the same price, and you ask them, well, like how do they wear out? Like how long does it take until the tire wears down to where it's unsafe? And they go, oh, this one's like 39,000 miles. This one's like 40,000 miles. So essentially, they have the exact same average lifetime of tire. So it's a coin flip to buy them. But then you think to yourself, wait a minute, hang on a second. Do you have any like raw data, or do you understand what's the plus or minus around that? And if they say the first one is plus or minus 10,000 miles,
Could you imagine?
and the other one is plus or minus 1,000 miles, that's going to make a huge difference on which tire you buy. At least it should. At least it should make a huge difference on how you're thinking about it. Because a tire, let me slide this over this way a little bit.
You think someone would be able to tell you that if you asked them?
The data's somewhere. I would hope they'd be able to. If you're trying to sell me tires that I'm putting my family in. This is exactly what you should be.
I feel like the dude would be like,
Then I'm gonna go find his boss. So let's say they both have an average of 40,000 miles. Okay? And tire A, for lack of a better name, tire A has a standard deviation of 10,000 miles. So we'll just throw 10,000 out here. So we'll go down 10 and up 10. And we'll get more of this. I love this plus or minus idea. This is Tammy's plus or minus. We're going to build this. In case this is not making sense right now, it'll make a lot of sense by the end of the day. Now, chances are, and we'll talk more about this today too, those tires are going to have some kind of a bell curve attached to them. So you've got a lot of tires that exist between 30,000 and 50,000 miles. There's a chance that they're not even going to last 30,000. You may have some defect tires. And there's a chance you get some really good batches that last really long time. So that's like tire A, if you will. Tire B has the same average, but it's only got a plus or minus of 2,000, I think I said, or 1,000. So it's going to be in here, say from 41,000 down to 39,000.
so your plus or minus is like what you're talking about, like margin of error or
Yes.
whatever? So it either could be this far or it could be this far.
With a certain percentage.
Yeah,
and
yeah.
that's what we're going to talk about today.
Yeah.
That's what we'll talk about today. Now, and Chris, you hit the nail on the head perfectly, actually. Assuming that both of these tires are bell-shaped distributions or symmetric unimodal like this, roughly 2/3 of the data should fall within one standard deviation. Well, even if the standard deviation is this tight, you still should have about 2/3 of the data in there. Which means, Lucas, as you just correctly drew, the curve for the green ones is going to look something like, imagine that goes up on the wall. Something along those lines. So in other words, 2/3 of the tires you buy in brand B are going to be between 39 and 41,000 miles. But 2/3 of the tires you buy in brand A are between 30 and 50,000. So the question is, yes, you probably have more of a chance to get the 50,000 in the brand A versus the brand B. But that's still not a very good chance.
Yeah.
It's more of a chance, but still not a very good chance. It's like if you buy 2 lottery tickets, you've doubled the chances of your winning. Yes, it still sucks. But you have doubled your chances, right? So it depends. Are you a gambler? If you're a gambler, you might take the gamble and say, yeah, but I might get that 50. Yeah, but you just as likely get that 30.
When you ask about warranties,
Well, sure. And the idea of a warranty is it mitigates some of this. It basically takes the whole curve and shifts it that way.
Well, I mean, I want consistency.
Well, then you would buy brand B.
I want you to tell me it's gonna be this.
Then
so
you,
it's not
as
this
close
or
as it
maybe
can,
this.
right? And that's the thing. Very often, you jokingly said, how's that guy gonna know that? These guys and girls do know that. They say, yeah, I've heard them lasting as long as this or as short as this. But you gotta make sure that data is coming from a source. A lot of times, when are people gonna talk about their tires? When they're crappy. These things suck. They blew up after 6 months of use. Boom. All of a sudden, you've got a data point down here. Did you hear from the person that ran them for 12 straight years? No, don't do this, by the way. But did you, 12 straight years safely? No, you didn't hear about this data point out here. So you gotta make sure your data's unbiased. But your point is well taken, Chris. I mean, it's the kind of data you have to dig for. But it's worth digging for. And some things are not worth digging for. Are you actually getting 12 ounces of Pepsi in your 12-ounce Pepsi? Not worth digging for. But putting your family in a vehicle and driving around, worth digging for.
are you kidding?
It's not, right, Shelby? It's not worth digging for. But certain things are. Life insurance costs. Safety for your house, safety for your family. Certain things are worth diving in for. When we were trying to choose health insurance plans, when I first came here, we spent days poring over data, running risk analysis on me and on my wife to see which made the most sense for us. Yeah, nobody does that, but everybody should do that. So anyway, some things are worth digging in for. Something worth digging. Cool-ish? Makes sense? All right, good. Let's come back over here. What I want to do now is I want to solidify some of this. We've got these wonderful definitions of center and spread. I want to apply it to a real set of data now. On your data sheet, the very first data set up there, it says a sample weight loss, a sample of weight loss of 35 subjects. Go ahead and read that little bit right there. Those playing the home game.
Might want to bring it back. Is it still fish hooked?
No, I fixed that.
Okay,
I
cool.
fixed that. Yeah. Actually, I might want to bring it back though. Well, that's not bad actually. And they can hit
Does it get it
pause.
all right there?
It does.
Really?
It does, yeah.
Wow.
Yeah.
Photos are amazing.
They are. I need something that zooms though. I need to work on a better
Yeah.
camera, the one that zooms. And we will. It's all a learning process.
I want to get one, but they're still so expensive.
Of course. Anybody else need one? Came in a little bit late, need one of these? Here we go. Absolutely, absolutely. Let's clear this whole board. So, there's the title of the study, should you want to dive in and actually extract what's going on in the study. I don't really care so much about what they found in the study. That's more like what 244 is about, is getting into the research study, posing hypotheses, testing hypotheses, things like that. I want to focus only on the data and what we can extract from the data. So what you have here are a list of weight losses of 35 individuals in the study. I don't know if they were, it's been a long time, I don't remember if it's from the meal replacement group or the traditional food group or if it's all of them together, I don't remember. And again, I'm not that concerned about it, whether it's all of them together or broken up. I just want to ask one thing. Based on this data, does the weight loss intervention appear to be working?
Yes.
A couple votes for yes. Tell me why, friends. Raphael, you were the first one I heard.
The frequency of how many people lost weight or the negative numbers are much higher than the frequency compared to those that gained weight.
So he's going straight for percentage. What is that percentage? Let's see real quick. So ignoring magnitude, going purely geographically. So we're going to make up a new statistic here, a percentage median, if you will. So we're going to line up the numbers as negative or positive. Forget the magnitude of negative or positive, but only focus on if they lost weight versus if they didn't lose weight. Does that make sense? Is that fair? Tabitha, go ahead. That's we need to define zero. To make it binomial, let's call zero they didn't lose weight. They maintained. So we'll make it negative and not negative. How's that sound? You hear what you just asked? That's a great question. How do you define the data? Really, that is, and you'll have entire classes devoted to this at OSU, research methods classes 1 and 2.
Please don't talk.
No, you should. If you're actually analyzing data like this, the definition of what you're measuring is crucial, absolutely crucial. So let's count real quick. I got 1, 2, 3, 4,
26 and 8. For a total of 3.
You got 26 negative numbers?
I got 25, but I trust you guys. I trust you guys because I heard two say 26 and I can't count. So that's 26 and 9, right? Because there's 35 total. Wait, no, 26 and
34 total.
there's 35 numbers.
Someone double
There's
check me.
35 numbers.
Oh, that's right. I
35 numbers?
Yes.
But I did
Maybe you
count.
shouldn't trust us.
Yes. So 26
Oh, we're counting
negatives and the rest.
So 9
Yeah,
positives.
right. That's what I said, right? Okay. So I can count sometimes.
Yeah, there's
My bad.
35 total.
Okay. So 26 negative out of 35, which is what percent? 26 negative numbers out of a total of 35.
74.
There you go. So roughly 3/4. Can I call that 3/4? Is that okay with you guys? Roughly 3 out of 4 people in the study lost weight. Is that a successful, and there's no correct answer to this. Is this a successful weight loss intervention?
Yes.
Yes.
By percentage, it sure seems like it. 75% chance of losing weight, that's probably better than most diets.
Yeah.
Right? That's probably better than most
Very
diets,
much
honestly,
better.
in all honesty. But now the question becomes, okay, that's a, how would you term that data? What kind of data would that be looked at? Ignoring the data I actually gave you for a moment and only looking at how we treated it, how would you quantify that? Would that be qualitative or quantitative? And I'm not saying there's one right answer for this.
Might be quantitative.
Quantitative, because you looked at whether the data was
Was positive result.
right, negative or non-negative. So you can call it, if anybody says qualitative, you'd also be correct, because you either lost weight or you didn't lose weight.
Yeah.
So if you look at it mathematically, which you kind of have to do to group the data, versus you define it verbally. So either one, either one. The problem with it is, what do we lose by doing it that way?
Yeah.
Wouldn't that be the next question out of somebody's mouth, right?
Yeah.
Oh, you lost weight? How much? How would you answer that?
Out of all the
74% as much as other people did. I don't know.
But we did. We can't say that though, Tabitha, can we? That's a great idea. 75% as much as other people, but that's not what we measured. We measured those that lost weight versus the total of the group. So we're gonna have to default to well, I've erased them now. They were on the board. Measures of center. And we're not gonna do any adding, Chris. Let the machines do it for us. Let's run one var stats on this data. So like Bert and Ernie yesterday, run this stuff through L1, right? Get it in L1, run one var stats, let's see what we got. Let's start the analysis of this data set. Let me see if I can do this so I can get the screen visible okay.
on my forehead. Remember calculator for math 243.
Yes, that would be helpful. Yes, otherwise you're doing a lot of adding by yourself. Stat edit. What is this? Oh, this was the 105 rolling the bike down the hill. 28 or 24 miles per hour yesterday, or
Nice.
last Thursday.
Nice.
Pretty stoked.
Was it pretty gravelly?
It was awesomely gravelly, kind of terrifying. I'm not gonna lie to you.
I have yet to slide down the whole thing.
Say that again, Corey. Go ahead.
You want to enter all these negatives?
Yeah, enter them all as negatives and positive. Enter everything. Just one big list, L1. Don't split it into L1 and L2. Keep it all in one big group. These are 35 individuals. Well, and again, Chris, it doesn't matter because the TI counts better than any of us can and much faster.
Yeah.
So that's, again, the beauty of trying to classify this stuff manually versus automatically. There's just so much you gain by letting technology take over. You just got to make sure, and I'm running the risk of, while I'm talking by doing this, putting the data in correctly. So I'm going to shut up right now and just keep entering.
Can't walk and chew gum. to see some psych studies.
I always like to see psych studies. And those, in my opinion, are amongst the hardest ones to define anything for.
They really are.
I mean, so difficult, right? So difficult, Cassie, because you have to define things like intelligence,
Yeah.
right? I mean, pain scales.
Who technically has a mental disorder? 'Cause there's so many different.
Where's the line? Where's the cutoff? Where's the sliding scale? I mean, it's so hard. And I know that psych often gets ripped for that. Oh, it's soft science. That makes it almost harder than it being a hard science.
Right?
Because you can't put like a stopwatch on a ball and roll it downhill and go, okay, it took 5.2 seconds.
Quantify it.
It's so hard to quantify things. And the things that are quantified very often are on weird scales that generally aren't ratio or integral. So very, very tricky. Very, very tricky. Oh, totally. We'll get into that too.
DSM.
So let's get, as Lucas said earlier, on this weight loss data. We've got our weight loss data. I still want to answer the question, does the weight loss plan appear to be working? We said yes. And I think that we're going to re-answer that question as yes, I think for the most part. But I also want to answer Athena's question is, okay, it's working, how well?